Hello guys, welcome to another video of the Cheshire Dev channel. Today I'm going to be solving another Leetcode problem. This is another video of the Leetcode series, and this is the problem I'm gonna be solving today is the group Anagrams from the Leetcode.io page, which by the way is the first medium problem I'm going to be solving in this series. The description of the problem says that given an array of strings, group all anagrams together into sublists. You may return the output in any order. Then they explain what an anagram is. And I gotta be honest, I should stop going through the hints when I start the exercise, because for some reason this page gives pretty much the solution for the problem. So in this case, the hint number 3 says we can simply use an array of size 26, since the character set is from A through C, to count the frequency of each character in a string. Then we can use this array as the key in the hash map to group the strings. So it pretty much tells us that we need to use a hash map, and the key of the hash map will be an array of 26 elements, where we're going to store the counter of how many letters we found in a word. So there is a problem that I solved before, which was, I think it was valid anagram, the name, and the counting logic for the words, it's there, but so I might not explain that a lot here. So what this means is, okay, we are going to create a map. So this will be my map, for example, and the key of the map will be a array, right? So the array will go from 0 to 25. All of the elements initialized as 0, and then we are going to store in that array the count of the words. So if we go here, we can use this array as an example. So how do we get the count? So what we have to do is we gotta go to the ASCII table, and we gotta get the decimal value of the character, and once we have it, we do a subtraction, the current letter of the word minus the letter A, and then we get the position of the element in this array. So it's kind of confusing if you do this for the first time. For me, it was confusing. I had to even draw a chart in Miro to understand this logic. But anyways, so let's say that we are going to store the count of act. So the array will start with 26 zeros, and okay, we're going to find A, for example. So A, it's in the first position of the array, the index 0. So if the array was something like if the array was something like this, from the first element to the 26th, so now that we found A here, so we're going to increase the counter, right? So A, then we are going to find C, so A, B, C, so this would be 1. Then in the middle we are going to find T, so we increase T, and the end, right? So this would be the C letter, but there is no C in that. So then this will become the key, and that key will store an array of strings, a list, it says, for example, with the word act. Then we're gonna go to cat, for example, and okay, let me copy this. And cat, it's pretty much the same. We are going to start off with a empty array, because we need to clean it for some, so yeah, we need to clean it. And then we are going to loop through cat. So C, okay, C, we found C. we increase the counter, then we find A, we increase the counter, and then we find T, we increase the counter. And as you can see, this is the exact same key as at. So we are going to add to this key this other value. So this would be cat. Then, for example, we could do the same for another word that's gonna be different than this one. So let's clean this. Now let's say, for example, bathe, for example, bathe. So bathe, it's this word, bathe. I think that's baby, it's and bathe. Okay, bathe. And let's say we loop through bathe and we find B, so we increase the counter. We find A, we increase the counter. We find E, A, B, C, D. Let's say that this is E. We increase the counter and then we find B again. Okay, we would have found B first before E, but whatever. So this would be the key of bathe, and B 2 times, A 1 time, E 1 time. And then we would create the array for this guy. And this is how the bathe word would be saved with this key. So that's pretty much the logic of the counter. Then we would have to extract these arrays and return them like this. So an array of arrays. Okay, I'm gonna keep this coming here. So I'm gonna create my map. This is going to be a default dict. I don't know if this is how you initialize for empty strings, for empty arrays. Then we need to loop through the words. So we gotta word in strings. Now for each word we have to loop through the letters. So we gotta go for letter in word, and then we gotta find the counter. So I cannot remember how this was. So first we find the index, which is going to be OR of the current letter. So this OR will return the decimal value minus the decimal value of A, right? And then, okay, we need to declare the map. So hold on. So we get the index. The counter. So count array would be 0 times 26, right? 26 letter, yes. And then count array at index. We are going to increase the counter. So this would be, this would start off as a lot of zeros, and then for each letter that we find, we're going to increase that counter in this position. Okay, now that we have the counter, we have to store it as a key, right? So my map at, this would be count array, would be equal to the word we are looping through, right? Going to be equal to the word. So we find the counter, we store it as a key, we store the word, but we have to return this. Okay, we have to, okay, now that we have the counter, we have to clean that counter. So what's the problem? If I don't clear the count array and set all the values to 0 again, this will be a problem. So I think So for each word that we are looping through, we are going to use a clean count array, right? Yes. So now we have to convert this array into a list. Let me create another function, convert to list. This will receive my map, and this will return a list of a string. And so we have to return, okay, I'm going to main array going to be equal to an array, then sub array or another array. So main array is what do I intend with this? So I have to return a list of strings. So this would be the main array, and this will hold all the sub arrays, and the sub arrays will be each will be the all the words for a key of the map, right? So I need to get all the keys. Map keys will be, I think, my map that keys. I think this is how you get the keys. Okay, now we have the keys stored here, and we need to loop through these keys. So for a key in map keys, so for each key I'm going to get the yes, for each key I'm going to get this array. So this would be sub array is going to be equal to my map at the key, and then I'm going to append this sub array to the main array, right? So append, I think, yeah, append, and we're going to append the sub array. Now that we have it like this, we are going to return the main array. So main sub array so we're going to get all these keys, right? So this will give me this key and this key. Then for this key I'm going to get these two strings, and I will store it here, not the strings, the array, right? And then I'm going to store this array into main array, and I'm going to do the same for babe, right? And then I'm going to return the main array, and this is what I'm going to return. So I'm going to return convert to list. I'm going to pass my map. So let's see, we create a map of empty arrays. We create the count array for the counter of each word. Now we get the counter, set it as a key, save the word, and we will get this, and then we return the list of lists. I think this is not gonna work because I am not appending anything, I'm replacing. Okay, let me hit run. Callable. A callable. First argument must be a callable or none. Okay, none. I'm going to set it as none. Cannot use list as a date key. Unhashable type. Unhashable. Okay, there is a thing with the maps, and the keys of the maps has to be immutable, and lists are not immutable. So tuple will turn this into an immutable type that we are going to be able to use in the key of the map. Now this will create an error here because if this is immutable, it means we cannot change it. Oh, so I let it, what? Self. Okay, self. Ah man, the self is if you wanna, yeah. So all the functions be inside the class should have the self. To be honest, I haven't watched or studied a Python course since I started this series, and I think I should have done that. Hold on. A string. A string object has not. Why strings? Why am I looping through strings? Bro, what does my map has? Yo, this guy has a. This is, you can see the key, but why am I storing? Yeah, here's a problem. Here there is a huge problem because as you can see there are only three letters, and the string in the string there are six. So it means I am replacing, I'm not appending. I am not appending. Let me array. So let me get the array. Then to this array I'm going to append the word, and then I'm going to save it in back to the map. Man, it doesn't say anything though. Key error. What does that mean? Key error. Why is this a? What does this mean? Key error. I write my map down at in process input. Listen, I don't know. I don't know if this is gonna solve it, but I didn't like. I think this would cause an error anyway. So let me. Bro, that wasn't gonna solve it. That didn't solve it. Key error. Is this how you turn the? Is this the function? Tuple. Okay, let me. How do I convert a mutable type to a mutable? So this is how you write it. Tuple, yeah, that's how you do it. Tuple. Tuple array, I set it here. This is a problem. I don't know why this is happening. Key error. Line 16. Whoa. So this key does not exist. Man, what is callable? Yo, like this. What? Lowercase. Man, I need to type Python because I can't keep working like this, man. This is awful. Cannot use list as a dict key and hashable type. Oh, this is tuple. Yo, do you see? I was gonna come across this problem anyways because here I'm changing the array. So yeah, I predicted that. Why did I work for the two cases? Hold on, let me see. Well, yo, why did it work? Hold on. Okay, I have the count array. I have this. This is a callable type. It's the same but in lowercase for some reason. I get the counter. This part is easy to see to understand. I turn the key into an immutable type. I get the array, append the word, and set it again. Then I pass this to convert to list. So okay, so I created two arrays. I get the keys. I loop through the keys. I get the subarray. I append the subarray to the main array. I return the main array. Now let me see if this is even optimal. What's the goal for this? Listen, because I'm looping n times per word per words, and then I am looping n times per letter. So that's n times m. Then I'm looping again n times per key. Then those are a lot of loops. And what? And then memory wise, I have a map. Bro, I don't know if this is even optimal because am I creating? Yo, can I remove that? Yeah, I'm creating a new array or just yeah, I'm creating a new one actually, and that new one is being used as a key. Then I'm creating another one as a tuple. Okay, it works for empty strings and gonna submit this. This might break. What? Bro, look at this runtime. This is oh hell no. Okay, memory wise, that 2 megabytes. That's a lot of, I mean, it's not that much, but anyways. But runtime, this is awful. This is awful. Yeah, I'm doing too many loops. Too many loops. I was gonna say, okay, this is the brute force approach, and it worked. So let me see what a nice code would look like. So I get the, okay, I create a dictionary for strings, sorted strings. It's sourced. Bro, I don't understand this code, to be honest. Okay, this is better. So I do this, I create the default dict, yes. I create the array, yes. Then I go for each character, index. Yeah, so far so good. Ants, what is, okay, the tuple dot append. Okay, I understand this part. I just get the values. I don't need to, okay, I can completely skip this part because the that values function returns what I'm looking for. So let me try that part. So I'm gonna turn this into a list and my map that values. So let me see if this even runs. Okay, runs. Let me submit this. Bro, this is way better. Way better. So I was doing too many loops. Okay, it was going through the keys. So that one loop, two loops, three loops. Yeah, that's it. Memory didn't improve. Memory didn't improve, by runtime it did improve. We went from here to here. Okay, so I think I'm gonna leave it here. That would be it for today, guys, and I'll see you next time.